This is IBM Museum. In this video, I'm going to do the modification of a Dallas DS1287 real-time clock chip. That's adding the external battery and disconnecting the flat internal battery start to finish. And I'm going to show the tools that I use. And I mean, I'm going to likely pause the video in portions that I need to collect IMs or something else if the situation calls for it. But I'd like to even just keep the timer rolling as far as how quickly I can do this. So normally I do a assembly line process. I have a few modules even right now on my bench, but I'm going to go through and modify just one start to finish so I can have an approximate time of what exactly this takes. So showing my tools, and of course you saw my safety glasses. I do have, and those are critical for those flying bits. I use these Dremels, and I have two Dremels here, even with different bits, even though you can change the bits and everything and just have one Dremel. And this is my primary scoring tool. What I do to cut slots into the sides of the Dallas modules to expose those positive and negative terminals inside to be able to connect up wires to those positions. And I'll show you where those are on the Dallas module. And then the drill Dremel, I have that for drilling in at the top of the chip to sever that internal battery connection once I've cut the slot into above the pins. And then I go through with the voltmeter. I measure to see if that voltage of the internal battery, to make sure it's flat, to make sure I do get that disconnected from the circuit that I patch into for the external battery. And then I've got some of the external battery holders I use. I've got a spool of wire, and even typically you can use, it doesn't even have to be all that much of a wire. As long as you know it's your positive and your negative leads. I have soldering flux for my soldering. I do have my soldering unit here. What's also helpful to have an X-Acto knife with a blade basically to cut into, or to just to remove that little bit of plastic, maybe to expose those leads. I have little wire cutters. I even have these insulation strippers that I go through, can put those short pieces of the wire in there to strip the leads away. Sometimes for these, I'll go through and even mount the battery holder on top of the chip, something like that. And so I don't even have that length of that long of wires that I have to do, and that can even be covered up with hot glue or whatever after the point, just to stop any wires being exposed. And I'll probably do that in this case. I'll probably go through and put that battery holder just so it goes through. It's not quite as low profile as you need in some situations. It does make in some of the systems like the 55SX, it can make it to where it's easy to get at that battery and change that out without necessarily going in there removing adapter cards or anything like that to get at the battery. So let's just get started here. I can move some of the stuff I don't need out of the way for the moment. I need even almost a timer. It'd be great if OBS would have a timer just to kind of show um, a running counter. And I'm cutting the negative terminal first. Okay, and you can see that little bit of contact that's been exposed for the negative side already, just that quickly. And typically this connection goes inwards, it slopes inwards towards the top of the module. And the internal battery is just right under here, and there's just that metal strap goes across because it connects up to the chip at the lower end, and it has a strap that goes up across the top of the battery for the negative side. And some of these, some modules, like the Odin modules I've heard, go through and they invert the battery. They put it underneath the chip, so it's a different mechanism. I'm just used to the Dallas modules. I'm going to go through, I'll start going after the positive side, and that's in this position here. I typically, on the side opposite the pin 1 marking, you have the 3 leads, the space for the negative side, the 3 leads, and the space for the positive side. And so let's get doing the positive side. Okay, and the same thing for it. Just that quick work, expose that contact. And you may want to expose more area. If you have flux and get your wire in there and get enough solder, I mean, it's going to bond to that. You can go through and notch these slots out to the top for a path for your wire connections there too. Normally I would, I can go in there and I can expose more of that negative side just to kind of see how it lays through the chip. Okay, so you can see on the negative side how that has gone through, and there's a narrow portion that's just right below, that's in here, and you have to look, and sometimes people will go through and they'll dig out with the X-Acto blades this connection up at the top, just to go through and sever it. I use that drill just to get in there, just being aware that strap, that metal strap to the battery can be wider than that notch, just slightly. And when you have both leads exposed, you want to go through and you want to check the voltage. Okay. And as I said, get my... Okay. So negative, and positive, we see a pretty relatively flat battery. You know, that's at a tenth of what it's supposed to be. Normally it would be 3 volts, and it's almost 0.3 volts. So let's go through. I'll go through and drill out the upper end of that. Okay, and once I got through the metal, and of course it jumped around a little bit, me holding it up. I mean, I could lay it flat, but once I got through that metal, it went into that plastic, and there's not really much below that strap. You have to really get back in there for that battery. But it looks like I've severed the connection between that upper side and lower side where we want to solder onto. And so we would go through positive side. Just my negative lead just wants to get in the way. These wires are not very flexible. Okay, so positive and negative sides. So we're not getting really any reading. If I go up to the positive side there, or up above where I've severed it, I get that 0.3 volts. Go below, I don't get anything. Up above, get 0.3. So I've got that internal battery severed. And I want to go through, I'll get my soldering iron powered on. I've dremeled away enough for soldering in there. Okay, as my soldering iron comes up to temp, and it looks like about 15 minutes as I've gone through and done. Well, no, it wouldn't be 15 minutes. Be just about 7 minutes, 8 minutes since I've gone through, and it's below 15 minutes even of recording time. And that's with all the narration and everything else that I've done. Let's get a good little tool to get into my flux. Just getting a little bit of flux down in here on these leads. Okay. Let's just do a short little piece. I could go through and even fix this to the top. That's a positive. And so generally what I do in a lot of cases is when I put this on the top, I remove this lead because both of these top leads are positive. Since the battery is positive on it has the positive face up. And then this is the single pin is the negative side. And so I would go through and I'd bend this one down, and I'd go down to bridge to the positive connection on this side, and then bridge a little L unit from that other side. But let me bend that one down. I want to bend. I'm going to bend this positive one. We could even clip this. And then let's bend the negative one. Like this. We don't want to bend them back and forth to break them loose or anything like that, but just get them flatter to be able to solder on our connections from there. And I have short little bits of wire, and I might just do kind of going through and stripping this wire just to give it a little bit of handle that I can work with to hold in as I solder, and then follow it up with and this is stranded wire. I'm going to use the copper colored or the copper wire on the positive side. And I think go through, get some flux on that. Just to have it like that, I think. Okay, so let's get some solder. Go through and clean my tip. Long had my soldering iron up to temperature. Okay. And I might stand even to still didn't bond. I'm not. Okay. A little bit more. Okay. So that bonded into the positive side. I think I'll do my negative side up. Let's trim away enough of piece there. Get those strands together. And that the high side of that internal battery, that's way back in there. So I'm not making any real contact with things. And get some more solder. I'll get it on my tip there. Okay, and that's bonded to the negative side. And so my battery holder is going to go over the top, just like that. I think I got some flux in there, but let's make sure we get a nut more. Okay. And just have some solder available here. Get on camera. As long as you have flux, you don't have to hit that for very long. Okay. So I can go through and I can even trim away that side. I'm wanting to just come up with a little L right here. Get some flux on that point. Okay. Need to hook up some solder here that I can. Okay. And just the cap deeper than what I think it is a lot of the time. Okay. So that bonded there. Go through with my snips, my wire cutters, and there I have a completion of what I need to solder for that battery holder. And the front of that's, of course, pulling on a battery out of there and everything else, you have a strain against that. But that doesn't even hardly need any glue or something else to fix that battery holder to the top of the module. And it's labeled as that positive for the side up. It would just be me going through, getting out the batteries that I have. Okay. Here's even a good old Duracell. I'm not getting any sponsorship from these guys. It's got the little kitty label, you know, protection. You don't want anybody swallowing these either. And lithium batteries, so you dispose of these. It's not supposed to be on your municipal trash. So positive to positive, you know. And at this point, this would be, can be put in the circuit. You could go through and, you know, put a little bit of electrical tape. Over the top of those contacts if you wanted to, you know, the scissors might be even better for me to have. Get into my scissor drawer, get everything out of the way of my scissor drawer. Okay. And fold that down. That's on a little bit, the contact there is a little bit on a recessed beneath the surface a little bit, but there's not really any exposed metal necessarily to my soldering job. There is that exposed battery, of course, being the biggest thing. But with some systems, what I'm saying is that module being in this position, it's easy to just grab and pull that battery out of the slot to swap it out. I mean, we've been ready to go there for a good minute, and that thing even looks professional. I'd put it, can put them side by side for the modification I've done. So that is the entire thing that needs to be done to modify a Dallas DS1287 module. So if you enjoyed this content, click on that like button, and as always, subscribe to my channel if you've not already. Invite your friends, get more subscribers to my channel. That'd be great. But this is the IBM Museum. That's all I have for now. Thank you.